Okay. Hey, everybody. I'm going to show you about functions today. So there's lesson chapter 4-6 on functions and mapping diagrams, and input and output and domain range. Those are the topics we'll be covering today. So I'm going to start with this up here. What's highlighted in yellow is kind of an important thing. It says if it's a function, every input must go to exactly one output. And we'll get to that in a little bit. Let me start off with this. Question 1 is identify the domain and range of the function, then draw a mapping diagram. Then determine whether it's a function or not. So if I start over here and I just start listing the domain is all the x values. Okay, so -2, that's part of the domain. 0, that's also part of the domain. 4, that's also part of the domain, and 5 is part of the domain. All right, so if you look over here, you can just see that, I'm just picking the x values out of the points here. 4 is an x coordinate, 5 is an x coordinate, so is -2 and 0. So those make up the domain. The other thing is the range. Along the same lines, the domain is the x values and the range is the y values. So if I'm looking at those points there, the y values would be 0.5, 2.5, 6.5, and 2.5 again. Now you don't list the numbers that repeat twice in the domain and the range. You just list it once, okay? Okay, next I'm going to make what's called a mapping diagram. So input and domain and x, they're really kind of the same thing when it comes to functions. All right, so all these domain numbers, -2, 0, 4, and 5, that's also the x values, it's the domain, and it's the inputs. So if I'm listing these, I can just list them right here in order. First I got -2, and then I got 0, and then I got 4, and the last one I have is 5. Now, and over here in the range, I'm going to have the corresponding, I'm going to put the 0.5 corresponding y values, 2.5, because 0 goes to 2.5, which we'll get to in a moment, 4, 6.5, okay, and then 2.5 again up here. But I'm not going to repeat them, okay, in the mapping diagram. All right, so next thing I'm going to do is we can draw arrows. So -2, -2 goes to 0.5. Whoa, grabbed the wrong thing. Oh no. This is my first time with this. All right, so let's see if I can get back over here. Get off of that and do my arrow. Here's the eraser. Bang. Okay, back to that. Sorry about that. Pen. Yes, pen. All right, so 2 goes to 0.5. 0 goes to 2.5. 4 goes to 6.5, and I'm just pulling these right out of the points. And the last one, 5 also goes to 2.5. So that one's got like a double arrow going at it. So when you're determining whether it's a function or not, you're going to look back and and say that driving question, does every input go to exactly one output? And you can see that each one of these inputs here, they go to one output. Even though two of them go to 2.5, that's okay. And you can say since every input goes to exactly one output, it is a function. All right, so that's the question. And you're going to be doing more of these. Second one's the same idea. Make a mapping diagram, then determine if it's a function or not. So I'm going to list these x values. This one doesn't ask me to determine the domain and range, so I'm just going to start listing them. I got 2 ones, so I'm going to leave it in the mapping diagram. And this thing here is my mapping diagram. So I got 2 ones so in the domain, or the inputs. So I also have a 2, and I have a 3 in the domain. And once again, those are just the x values. Now I'm going to put the range and the outputs over here, which are the same thing. And in the y values, I got 6. I also have a 7, an 8, and a 9. Okay, and part of the mapping diagram is the arrows then. So 1 goes to 6, 1 goes to 7, so this one's got like a double arrow. 2 goes to 8, and 3 goes to 9. And then you're asking yourself that same driving question. Did every input go to exactly one output? And the answer to this one is no, since one input has more than one output, it is not a function. Okay, so that's that question. We figured it out because of this one right here. That 1 goes to 6 and 7, therefore it's not a function. Question 3. Move that other stuff. Can't move that other ones. Maybe I'll move question 3 for a moment. So all right, so question 3. Sorry, I'm having troubles with the layout. So same idea, mapping function, determine whether it's a function or not. So under the x values, I can put a 1. I also put a 2 and a 3. And under the y values, for the range and output, I get 6, 7, and 7. So since I have more than one 7, I only list it once in the mapping diagram, and then I can do my arrows. So 1 goes to 6, 2 goes to 7, and 3 also goes to 7. And you can see then that the answer to the question of whether it's a function or not is no, it's not a function because, oh wait, it is a function because every input goes to exactly one output. I was thinking because 2 of them went to 7, it wasn't, but in fact, it is a function. All right, so that's the answer number 3. Now the other thing, and this got moved, is, with my drawings here, a function must pass the vertical line test, which means this is the first graph here, and I apologize, it's kind of overlapped there, but you know, if I put a vertical line through there, anywhere on that graph, does it hit the function, in this case it's a blue line, in more than one spot? If it does hit it in more than one spot, then it's not a function. If it only hits it in one spot, then you're okay. It's not a, it is a function if it's only one spot. So if I put a vertical line right through here, does it hit the blue line in more than one spot or only one spot? One spot, one spot. You can see the red lines are my vertical lines. Vertical means up and down. So you choose any spot you want on there, put a vertical line through it, and see, is it a function? In this case, it only hits the blue line at one spot, therefore it is a function. If I move over to the right to a couple of my other examples here, this one, it only hits it in one spot there, and I know even though it looks like, this starts getting pretty steep, but that vertical line still only hits that blue curve in one spot, which means that one's a function also. You can see all the vertical lines hit it only in one spot. Now this one over here, that was number 4 here, that one's number 5, and this one's number 6, even though my things got moved around a little bit. This one's different. You see how that red line, the vertical line, hits that blue curve in 2 spots? That one's not a function, all right? So the first 2 are functions, and this third one here is not a function. So that's a nice way. If they give you a graph, the easiest way to determine whether something's a function or not is the vertical line test. Start visualizing, putting vertical lines through there, and see, does it pass the vertical line test or not? All right. And if it's points, sometimes it might be points. If I put a vertical line through, does it hit more than one point? Sometimes you'll see that as well. All right. So that's 12 and a half minutes. And that's the end of my my lesson on functions for today. Thank you very much. See you later.